Hello everyone. In this second part of Eudiometry, we are gonna talk about some common reactions that occur in Eudiometer tube. The first type of reaction that commonly occurs in Eudiometer tube is combustion reaction. So we'll write few examples of combustion reaction that commonly takes place in Eudiometer tube. The first type of reaction is CXHY plus X plus Y by 4 times O2 giving us XCO2 plus Y by 2 S2O. The second type of reaction that occurs here is CXHYOZ plus X plus Y by 4 plus Z by 2 of O2 giving us XCO2 plus Y by 2 of S2O plus 2ZO2. The third type of reaction that occurs as a combustion reaction is N2 plus O2. This will give us no product because this reaction will never occur. It's just a reminder for you that never react N2 and O2 in Eudiometer tube. The fourth type of reaction is CO2 plus half O2 giving us CO2. Then CXHYNZ plus X plus Y by 4 O2 giving us XCO2 plus Y by 2 of S2O plus Z by 2 of N2. This reaction is very similar to the second one. The sixth type of reaction is S2 in gaseous state combined with half of O2 in gaseous state giving us H2O in liquid state. So these are common reactions that occur in Eudiometer tube, which is part of combustion reaction CXHY plus X plus Y by 4 O2 giving us XCO2 plus Y by 2 H2O. Similarly, the second one, just the stoichiometric coefficient for O2 is changed. The third one will never occur. In fourth one, it is CO plus half O2 giving us CO2, not CO2 plus half O2. It's CO plus half O2. The fifth reaction is very similar to the second one. Just you have to take care of balancing. Now moving further, we'll discuss second type of reaction that commonly occurs in Eudiometer tube, that is decomposition reaction. We'll write few examples of decomposition reaction as well, so you can better recognize in a problem whenever you see such reactions. So NH3 decomposes into half N2 plus 3 by 2 moles of H2. Also N2 and H2 will be in gaseous state. Similarly NXHY, which is in gaseous state, will go decompose into X by 2 of N2 gaseous state plus Y by 2 of H2 in gaseous state. O3, ozone in gaseous state, will decompose into 3 by 2 moles of O2 in gaseous state. Also OX in gaseous state will go into X by 2 of O2 in gaseous state. You can simply see the symmetry in these reactions. The first and second one, the third and fourth one, they are basically, we have just put the values or just an examples to show how these reactions occur. One more important thing is here that you should always check whether balancing is done or not for reaction to occur. Now moving further, here's a problem. 50 ml of propane is mixed with 300 ml of O2 and mixture is then ignited. Find out volume contraction or volume expansion. So we'll write the solution here. Propane is mixed with, so for propane we'll write the formula CXHY plus X plus Y by 4 of O2 giving us XCO2 plus Y by 2 H2O. This is how we write a combustion reaction, right? We discussed in combustion part. Now you know the formula for propane, it is C3H8. So instead of X we'll write 3 and instead of Y we'll write 8. And similarly we'll put these values here for X and Y, XCO2 plus Y by 2 of H2O. So we can clearly observe that X is 3 and Y is 8, right? So X plus Y by 4, which is the coefficient of O2, it will be 3 plus 8 by 4, which will come out to be 5. So 5 O2 giving us X CO2. X is 3 CO2 plus 8 by 2 of H2O, which is 4. So this is our final reaction which is occurring here. The stoichiometric coefficient for C3H8 is 1. So we'll write here 1 mole of C3H8 combines with 5 mole of oxygen to form 3 moles of CO2 and 4 moles of H2O. This is one here. Also, what we are given here, that 50 ml of propane is mixed with 300 ml of O2, right? So at time t equal to 0, we have 50 ml of propane and 300 ml of O2, right? This is at t equal to 0 and t equal to t, and the reaction will be complete. We don't know how much moles of CO2 will be formed and H2O will be formed, but first we'll find the LR here. So for C3H8 we can write 50 divided by 1, it will come out to be simply 50. Similarly for O2 it will be 300 divided by 5, it will come out to be 60. So clearly we can see that the lesser value is for C3H8, so it will be our LR. It will determine how much product will be formed or reactant will be left. C3H8 will be left 0 milliliters. Also 1 mole of C3H8 reacts with 5 moles of O2, right? So 50 milliliters of C3H8 will react with how much volume of O2? It will be simply 5 multiplied by 50. 50 multiplied by 5. So this is how much O2 will be reacted in this reaction. It will be 250 milliliters, right? So how much will be left? 300 minus 250. It will come out to be 50 milliliters. 300 minus 250. So 50 ml is left for oxygen, and similarly how much CO2 will be formed? How much water will be formed? It will be nothing because it's in liquid state. For CO2 we can simply use unitary method. So 1 mole of C3H8 forms 3 mole of CO2. So 50 ml of C3H8 will form 3 multiplied by 50, which is 150 ml of CO2. So initial volume is 50 plus 300 milliliters. It will come out to be 350 ml, right? Similarly, the final volume, it is 0 plus 50 plus 150 plus 0 again. It will come out to be 50 plus 150, which is 200 ml. We had to find volume contraction or volume expansion, right? So here we can clearly observe that initial volume is greater than final volume, so volume contraction has occurred here. So the formula for volume contraction is Vi minus Vf, initial volume minus final volume. It will come out to be 350 minus 200. It will be 150 milliliters. So this will simply be our answer in this case. Now moving further, here 10 milliliters of an alkane on complete combustion gives 30 ml of CO2. Then determine the formula of alkane. Now we have to find the formula for alkane. Here we are given that there's some alkane. The formula will be CXHY plus X plus Y by 4 of O2, giving us XCO2 plus Y by 2 H2O, because it's undergoing combustion, right? So simply CXHY plus X plus Y by 4 O2, giving us XCO2 plus Y by 2 of H2O, right? As per the problem, at t equal to 0, we are given 10 milliliters of CXHY is taken on complete combustion. Means this should also be 10 in order to undergo complete combustion, and it forms 30 milliliters of CO2, right? So for CO2 it's 30 ml, and for H2O there would be no H2O in liquid state. We won't consider its volume. Okay, so simply use unitary method. By observation we can see X should be 30, and similarly this value X plus Y by 4, the mod of X plus Y by 4 should be equal to 10. Now solving it, X is 30 plus Y by 4 is equal to 10. We are using here modulus to determine the value of Y. So Y by 4 will be equal to 20, so Y will come out to be 80. So the formula for this alkane is CXHY, which is C30. The formula is C30H80. On simplifying, it will come out to be C3H8. So this is our answer in this case. Now moving further, we'll solve another problem. Here 10 ml of hydrocarbon gas CXH5 on complete combustion gives 30 ml of CO2. For this 40 ml of O2 is required. Find out the formula for hydrocarbon. So we'll simply write CXHY plus X plus Y by 4 of O2, giving us XCO2 plus Y by 2 of H2O, right? Initially we are given that 10 milliliters of CXHY, which is hydrocarbon gas here, and 40 ml of O2 is taken for complete combustion. Here 30 milliliters of CO2 is formed, and for water we won't consider its volume, right, because it's in liquid state. Here it will be 0, here it will be 0. For complete combustion these values should be 0, right? Now we'll simply use observation. Here x plus 5 by 4 should be equal to 40, and similarly x should be equal to 30 for this reaction to be balanced. Now simply putting the value of x in the first equation, y will come out to be 40. So the formula for this hydrocarbon is CXHY, which is C30H40, right? C30H40. On simplification, it will come out to be C3H4. So this is the formula for this hydrocarbon. Hope you understand this.